On a December night in 2018, a wave came out of the dark with no earthquake and no warning, and it killed more than 400 people along the coasts of Java and Sumatra. It came from one volcano, Anak Krakatau. This week, that same volcano erupted 6 times in under 10 hours, and Indonesia raised its alert to the second highest level on its scale. The question now is whether that silent wave is being loaded again. Here is the worst case, and the signals that would warn us it is coming. In a single stretch of less than 10 hours on July 8th, the volcano known as Anak Krakatau erupted 6 separate times. 6 distinct pulses, one after another, from a crater sitting in the middle of one of the busiest, most populated stretches of water in the world. The first came just after midnight, at around 11 minutes past 12 local time. It was too dark to see the ash column clearly, but the seismograph felt it, recording a signal with a maximum amplitude of 24 millimeters that lasted about 40 seconds. Then the sun came up, and the volcano kept going. By late morning, it had erupted 5 more times, and the last of the 6 was counted just before 10 a.m. This is the same volcano we looked at a little over 2 weeks ago when it was first stirring back to life. Back then, it was quieter. It was pushing up a pale, gray-white plume, only about 100 meters above the crater, and Indonesia's volcanology agency had it sitting at the second rung of the country's 4-level alert system, with a 2-kilometer ring of water closed off around it. The story then was that it had woken up. The story now is different, and it's more concerning. The story now is the direction it's moving. Because in those 2 weeks, almost everything about this eruption has been trending in the wrong direction. The alert level has been raised a full step. The closed-off zone around the crater has grown. The eruptions have gone from occasional isolated puffs to clustered bursts stacked one on top of the next. And the ash itself has been getting darker. What you're watching is not a single dramatic explosion. It's an escalation in real time at a volcano that has already killed hundreds of people once, and did it without any warning at all. Let's start with the official picture, because the people who watch this volcano for a living have already told us how seriously they're taking it. On July 2nd, at 4:30 in the afternoon local time, Indonesia's volcanology agency raised Anak Krakatau to alert level 3. On their scale, that's called Siaga, and it's the second highest of 4 levels. Level 1 is normal. Level 2, Waspada, means elevated unrest. Level 3, Siaga, is the one where the agency is telling you an eruption is either underway or considered likely, and it comes with restrictions. Level 4, Awas, is the top, the one that means a major eruption is imminent or already happening. So the volcano is now one single step below the highest alert Indonesia issues, and that step up wasn't a formality. Along with it, the exclusion zone around the active crater was widened from 2 kilometers out to 3. Roughly 1 mile and 9/10 of open water in every direction, that residents, tourists, fishermen, and boats are all now told to stay out of. The hazards the agency specifically flagged at this level are worth hearing in plain language. Hot clouds of pyroclastic material, lava, glowing chunks of rock thrown from the vent, and heavy ash fall around the crater. Here's why that alert level change is the anchor for everything else. An alert level is not a weather forecast that a computer spits out automatically. It's a judgment call made by scientists who are staring at seismographs and satellite feeds all day. And every step up carries a real economic cost. Because it shuts down fishing grounds, tourism, and shipping lanes, agencies do not raise these levels casually, and they do not raise them for show. When they moved Anak Krakatau up to level 3 and expanded the danger zone, they were making a costly, visible statement that the risk had genuinely climbed. That single decision is the most reliable signal we have, and it points in one direction. Now let's look at what they were seeing that drove that decision, because you can read this volcano's mood in 2 things: the color of its ash and the shaking underneath it. Start with the ash. During this sequence, the crater emissions ranged across 3 colors, white, gray, and black, and that color scale is essentially a thermometer for how violent the activity is. White is mostly steam. A volcano can quietly breathe out white steam for a very long time without doing anything dangerous. Gray means ash is starting to mix in. And black means dense, fresh, fragmented rock being blasted out of the vent. Black ash is the sign that the system has stopped merely venting gas and started tearing itself apart and throwing the pieces skyward. Over the sequence, the ash darkened from white through gray to black, and the columns climbed as high as around 250 meters, a little over 800 feet above the summit. But the color change is only half the story. The other half is buried in the ground in the seismic signal, and it lines up with the ash almost perfectly. Across the pulses on July 8th, the strength of the seismic signals actually climbed. The first, in the dark after midnight, measured that maximum amplitude of 24 millimeters. The one at 10 to 6 in the morning came in at 26.1, and the one just after 7 a.m. jumped to 44.4 millimeters, nearly double the first. The volcano wasn't just erupting more often, each burst was hitting harder, and crucially, it wasn't going quiet in between. The monitoring during this phase showed intense, sustained volcanic tremor. Not sharp, individual earthquakes, but a continuous vibration running through the volcano's internal plumbing. That kind of tremor is the fingerprint of gas, magma, and pressurized fluid on the move inside the mountain. A representative day's tally included eruption earthquakes, emission events, harmonic tremor, low-frequency events, and more than a dozen hybrid, multi-phase events, a mix that translates, roughly, to rock cracking while fluid forces its way through it. Put simply, between the visible bursts, the volcano was still charging. It never settled down. That's what a pressurized, shallow, active system looks like from the outside, and it's why the alert stayed pinned at level 3. It's worth pausing on what those different tremor types actually tell us, because together they read almost like a diagnosis. The low-frequency events are the signature of gas, magma, or pressurized fluid moving through the conduits inside the mountain. The harmonic tremor, a steady, almost musical resonance, means the whole system is vibrating in sympathy, the way a single organ note can fill a room. And the hybrid events, the most numerous of all, are the most telling. They combine the sharp crack of rock breaking with the low rumble of fluid on the move, which is exactly what you'd expect from magma, forcing new pathways open as it pushes toward the surface. None of those signals on its own is a prediction, but stacked together, day after day, with the eruptions layered on top, they describe a volcano that is loaded and working, not one drifting back toward sleep. There's one apparent contradiction worth clearing up, because if you followed this story across different sources, you may have seen it. Observers standing near the volcano reported fairly modest plume heights, tens of meters to a couple hundred meters above the crater. But at the same time, satellite and aviation monitoring showed ash spreading out at altitude, drifting for miles over the strait. The Darwin Volcanic Ash Advisory Center, using the Himawari 9 weather satellite, tracked ash at one point as high as flight level 050, around 15,000 feet, or roughly 4,600 meters. Later advisories showed it continuing at a lower altitude, around 3,000 feet, drifting mainly to the southwest. So which is it? A small plume, or ash 15,000 feet up? The answer is both, and understanding why matters. The ground observers are reporting what they can see directly above the crater in the moment. The satellite is detecting the ash cloud after it has already risen, spread, and drifted away from the volcano. The two instruments are simply looking at different parts of the same cloud at different times. It's not a data problem, and it's not anyone hiding anything. It's the difference between watching smoke leave a chimney and watching that same smoke fan out across the neighborhood 10 minutes later. The reliable takeaway from both views is identical. This volcano is actively, persistently erupting, and the ash is reaching altitudes that matter for aircraft. Now we get to the part that separates Anak Krakatau from almost every other erupting volcano on Earth. And it's the reason the title of this video calls it one of the most dangerous. It's not the height of its ash columns. 250 meters of ash is, frankly, modest as volcanic eruptions go. The danger is in what this volcano is, physically, and where it sits. Anak Krakatau is an island volcano, and I want to be precise about what that means, because it's the whole story. The island is the volcano. There's no separate landmass with a mountain on it. The entire island is a cone of loosely stacked fresh volcanic material, built up out of deep water, rising straight out of the sea. Its name means Child of Krakatoa, and it earned that name by being born inside the drowned crater left behind when its monstrous parent tore itself apart in 1883. It first pushed above the waves in the late 1920s, and it has been building itself up, eruption by eruption, ever since. And location is everything here. Anak Krakatau sits in the Sunda Strait, the narrow channel of water that separates the island of Sumatra. To the west, from Java to the east. To the north and south of it lie some of the most trafficked waters on Earth. Fishing grounds, coastal towns, ferry routes, and one of the world's major shipping corridors linking the Indian Ocean to the busy seas of Southeast Asia. This is not some remote peak in an empty wilderness where an eruption threatens no one. It's a live volcano sitting in the middle of a crowded maritime neighborhood with populated coastlines on both sides, close enough that a wave born here would have almost no distance to travel before it reached people. On land, a volcano this active would be a regional nuisance. Some ashfall, a few flight cancellations, a closed zone around the crater. Put that exact same activity on an unstable island in a narrow populated strait, and the entire arithmetic of risk changes. It's worth understanding, briefly, why a volcano exists in this spot at all. because the same force that built it is the force now loading it. Deep beneath the strait, the Indo-Australian tectonic plate is grinding downward beneath the Sunda plate along the Sunda Trench in a slow-motion process called subduction. As that slab of ocean floor is dragged down into the hot interior of the planet, it releases fluids that melt the rock above it, and that molten rock rises to feed a long chain of volcanoes running the entire length of Indonesia. Krakatau is one link in that chain, which is itself part of the vast Pacific Ring of Fire. The plates move at only centimeters a year, about the rate your fingernails grow, but they never stop, and over the long run, that patient, relentless pressure is what powers everything we've been describing. When a volcano like this erupts, it carries every ordinary volcanic hazard: the ashfall, the glowing ejecta, the flying rock, the pyroclastic flows, the volcanic gas. But it carries one more that most volcanoes simply do not, because it's a loosely built pile of fresh rock standing in deep water. An eruption can destabilize the cone itself, and a piece of it, a flank, can break away and slide into the sea. And when a large mass of mountain suddenly drops into the ocean, it shoves the water outward in a wave. A tsunami, not one triggered by an earthquake, with all the seismic warning that comes with a quake. A tsunami triggered by the volcano collapsing part of itself, arriving with no shaking, no alarm, and no countdown. That is the specific, unusual danger that makes this particular volcano so closely watched every single time its activity climbs. So let's talk directly about the worst case, because that's what the title promised, and it deserves an honest answer rather than a scary one. The nightmare scenario for Anak Krakatau is not a bigger ash column. It's a chain reaction. It goes like this. The eruptions continue and load fresh, unstable material onto an already steep cone. That loading, combined with the shaking and the pressure of the eruption itself, destabilizes one of the flanks. A section of the island gives way and collapses into the sea. The falling mass displaces a huge volume of water, and that water races outward as a tsunami toward coastlines that had no earthquake, no felt shaking, no natural warning that anything was coming. Every link in that chain is physically real for this volcano. The ash column that we've been tracking is not itself the disaster. The ash column is the symptom. It's the volcano telling you that its internal system is energized and under pressure. The thing to actually watch, the place where the real danger lives, is the stability of the island itself. And here's the part that makes it so unnerving. Right now, our instruments are very good at seeing the ash. They can measure the plume, track the drift, log every tremor. What they cannot yet do, cleanly and in real time, is see inside the island and tell us exactly how stable that rebuilding cone is. We can watch the volcano breathe. We can't easily watch it lean. I want to be careful and fair here, because honesty is worth more than fear. This chain reaction is a low probability event. It is not what usually happens, even during an active eruptive phase. It's the tail risk, the unlikely but catastrophic outcome sitting at the far end of the range of possibilities. But the reason scientists take the tail so seriously at this volcano, and not just as a thought experiment, is that we are not guessing about whether it can happen. We know it can, because it already did, and not in the distant past. On the night of December 22nd, 2018, during an eruption, part of Anak Krakatau's southwestern flank failed. A landslide, estimated at less than about 0.2 of a cubic kilometer of material, broke away from the cone and crashed into the sea. There was no large earthquake beforehand, no ground shaking anyone could feel, none of the classic seismic signals that tsunami warning systems around the world are built to detect. The wave was generated entirely by the volcano dropping a piece of itself into the water, and it arrived at the worst possible moment. It came ashore, roughly between 9:30 and 10 o'clock at night, along the Sunda Strait coasts of Java and Sumatra, with run-ups reaching as high as around 13 meters, better than 40 feet, on some of the adjacent coasts. It was night. It was a holiday period. Beaches and coastal resorts were full of people, many of them close to the water, none of them expecting anything, because nothing had warned them. There had been no shaking to send anyone running for high ground. The first sign of the tsunami, for most of the people in its path, was the tsunami itself. Think about what that means in practice. Nearly every tsunami safety instinct that gets drilled into people who live near the ocean starts with the same trigger. If the ground shakes hard, get to high ground immediately. But that rule assumes there's an earthquake to feel. Here, there was none. The volcano skipped the warning stage entirely and went straight to the wave. The people on those beaches had no cue to run from, because the one signal they'd been taught to wait for simply never came. That is the cruelty of a flank collapse tsunami, and it's the precise reason this specific hazard sits in a category of its own. At least 437 people were killed, thousands more were injured, and tens of thousands were displaced from their homes. It was the deadliest volcanically triggered tsunami the world had seen since the 1883 catastrophe here. And it is the single most important fact in this entire story, because it takes the flank collapse scenario out of the realm of theory. This exact volcano, using this exact mechanism, has already killed hundreds of people once, in the modern era, on a night not so different from a night this month. That is why the current escalation is not being treated as a spectacle. That is why the alert is at level 3, and the water is closed off for 3 kilometers around. The people who raised that alert are looking at the same escalation you are, and they are remembering December 2018. If 2018 is the recent proof, then 1883 is the historical shadow that hangs over everything here, and it's where the name Krakatoa comes from. The original volcanic island of Krakatoa sat in this same Sunda Strait, and after months of building activity, on August 27, 1883, it produced one of the most destructive volcanic events in all of recorded history. It's estimated at a magnitude 6 on the volcanic explosivity index. It destroyed more than 70% of the island and the surrounding archipelago, and what was left collapsed down into its own emptied crater. The numbers from that day are almost hard to believe. The main explosion is considered one of the loudest sounds ever recorded on the planet. It was heard about 3,100 kilometers away, nearly 2,000 miles, in Perth in Western Australia. It was heard about 4,800 kilometers away near Rodriguez Island, out by Mauritius. The pressure wave from the blast circled the entire globe multiple times before it faded. At least 36,000 people were killed, the vast majority of them not by the explosion itself, but by the tsunamis it generated, with the largest local waves reaching on the order of 40 meters, over 130 feet. It threw so much ash and sulfur into the high atmosphere that it dimmed sunlight worldwide and cooled the entire planet's average temperature by roughly 0.6 of a degree Celsius in the period that followed. To give that scale a frame of reference, in the grim ledger of modern volcanic history, the 1883 Krakatoa eruption is usually ranked second in deadliness only to the eruption of Tambora, another Indonesian volcano, back in 1815. Tambora killed on the order of 60,000 people, and it threw so much material into the atmosphere that it triggered what came to be called the year without a summer. 1816, when crops failed across the northern hemisphere. Snow fell in June in New England, and famine followed in parts of Europe. That is the neighborhood of catastrophe this region is capable of producing at its most extreme. It's also a large part of why the name Krakatoa still carries the weight it does, well over a century later. Now, here's where I have to be straight with you, because it would be easy to let 1883 do the scaring for me, and that wouldn't be fair. What is erupting today is the child, not the parent. Anak Krakatau, the cone we're watching now, is a young, much smaller structure that has been growing inside the caldera the 1883 collapse left behind. It is nowhere near the size or the state of the volcano that produced that catastrophe. The current activity, those 250-meter ash columns, those moderate seismic amplitudes, does not indicate a repeat of 1883 is brewing. 1883 is the ceiling of what this location is capable of over centuries, not a forecast for this month. The honest danger for today is the smaller, more specific one. The flank collapse, the silent wave, the 2018 scenario, not the parent's apocalypse. Whenever a volcano makes headlines, a familiar set of claims starts circulating online, and it's worth addressing them quickly, because the truth here is actually more useful than the myth. The first claim is that the eruption is somehow engineered. Weather modification, directed energy, a human hand behind it. The problem is one of raw physics. The energy involved in even a modest eruptive sequence like this one is orders of magnitude beyond anything human technology can produce or steer. This behavior is fully and completely explained by molten rock rising from a subduction zone through a young, unstable cone. There's nothing left over for a secret machine to explain. The second claim is the opposite, that authorities are hiding a coming mega eruption, another 1883. But look at what the agency actually did. It raised the alert level. It expanded the exclusion zone. It shut down fishing and tourism and shipping. Those are visible, public, economically painful actions, the exact opposite of a cover-up. If anything, the official response has been to make the risk more visible, not less. And the third claim, that solar activity or some planetary alignment is triggering the eruption, runs into the same wall as the first. There's no established physical mechanism that links those cosmic cycles to the initiation of an individual eruption at this energy scale. The driver here is the same one that has driven this arc for millions of years, one tectonic plate grinding down beneath another. The real hazard is smaller than the myths, but it's far more specific and far more worth your attention. It's the island itself. So where does that leave us, and what should you actually watch for in the days ahead? The correct posture here is vigilance, not panics, and those are genuinely different things. This is a real escalating eruptive phase at a volcano with a demonstrated ability to kill without warning. It is also not, on the evidence in front of us, a confirmed imminent flank collapse or a repeat of the parent eruption. Both of those things are true at the same time, and holding both is the honest way to understand this. There are 3 concrete signals the monitoring teams are watching, and now you can watch them too. The first is the alert level itself. Does it hold at level 3, ease back toward level 2, or climb to level 4, always the top of the scale? A move to level 4 would be driven by things like sustained black ash, rising tremor, visible glowing rock at the summit, or measured swelling of the ground. The second, and this is the single most important one, is any sign of deformation or instability on that southwestern sector of the cone, the same flank that failed in 2018. That's the measurement that speaks directly to the tsunami risk, and it's the hardest one to read from ash observations alone. And the third is the tempo. Do the eruptions keep clustering, multiple pulses in a day the way they did on July 8th, or do they fall back to isolated puffs? That answer tells us whether this system is still intensifying or finally beginning to vent itself down. Here's the bottom line. There's an honest caveat that cuts in our favor. Because the volcano lost so much of its height in 2018, the cone today is lower and less massive than the one that collapsed, which lowers the odds of an identical full-scale southwestern flank failure right now. But lower probability is not zero probability. The cone is rebuilding from fresh, loose material, the system underneath it is clearly pressurized, and the alert sits at level 3 for good reasons. So we keep watching the ash for what it tells us about the pressure inside, and we keep watching the island itself for the thing that actually matters. Because at this volcano, in this strait, the danger has never been the sound it makes. The danger has always been the wave that comes with no sound at all. We'll be tracking it, and we'll tell you the moment those signals change.